The first part of the water cycle we're going to talk about is evaporation. Now, there's not really necessarily steps in the water cycle because it is, as definition, called a cycle. So there's not really first, second, or third step, but generally speaking, the first part you start with is evaporation because, well, it's the easiest place to start. So here we have a pot of water. It is on the stove, and the stove is on, as you can see. Now, this represents evaporation, and you can see you hopefully can see that there's steam starting to rise from the pot of water. So what that's doing, what's happening is all the water molecules in the pot are getting really excited, and when they get excited, they start jumping out into the air. And that's what you're seeing with the steam. It's pretty cool. Now, obviously you don't see steam rising up way up high because as it continues to rise, it cools down. But all of that, all of those water molecules getting hot, they're jumping up and evaporating. That's water vapor. That's excited water molecules that you're seeing. So let's take a look actually in the pot. You can see all of those water molecules getting really, really excited. And let's see, you can see the actual water vapor. If I hold it there, so you can see it right at the surface of the water. All of those excited water molecules are jumping into the air. It's pretty nifty. Now, there's the heat source. All right, now obviously this is on a stove and the heat source is coming from beneath the pot from the stove using natural gas burning it. Now, in the actual water cycle, there is no stove. There is no natural gas burning. What the energy is that heats up the water that's outside in lakes and rivers and streams, the ocean, that little puddle of water in your driveway that you always seem to step in when you're trying to get into your car after it rains and your shoe gets all wet and your sock gets all soggy. Getting off topic a little bit there, but it's the sun that warms up the water and makes the water evaporate. So there is no actual stove. But this is still a great representation of evaporation because you can see the water molecules getting excited visually, and you can see all the water vapor rising. Evaporation. Our next part of our water cycle, again, it's not really steps because it's a full cycle, but the next part of it is going to be condensation. So we just looked at how evaporation affects water molecules by getting them excited and releasing them into the air. They jump into the air, but once they get high enough in the sky, they start to cool down and they collect again. And that's called condensation. Now in our freezer, in my freezer here, I have a glass that's been chilling for a few minutes now, and so we're going to see what happens when I take it out of the freezer and into the air at room temperature. Right? So, as you can see, it's all cloudy now. So what's happening is all of the water molecules that are surrounding it in the air are collecting to it. They're sticking to it. So all of that kind of fogginess that you see on that glass is all the water molecules that are sticking to it because it's a lot colder than the air around it. All right. Now, obviously, in the sky, there are no glasses. There are no cups way up in the sky that I know of. I hope not, because I don't want to get hit in the head with a cup. But instead, because water molecules cannot collect anything that's not there. So they have to have something there to stick to. So up in the air, we have dust and all those particles up in the air that the water can stick to. So when you see clouds, that's what's happening, is all those water molecules are sticking to those dust particles in the air, and they're forming clouds. And of course, once those clouds get big enough, once the water gets heavy enough, it falls back to the ground as precipitation, which we'll get to in a second. That's kind of what can happen if you run your finger down the glass. No, never mind. I thought it would be cooler than that. Oh well. But that is condensation. It's just all those water molecules sticking to something. It's So here it was a glass, so when you go to a restaurant and you have a glass of ice water, iced tea, or soda, or whatever you're drinking, all of those water molecules stick to that glass. That's condensation. We call it, our drink is sweating. But it's not really sweating. It doesn't have sweat glands. It's just condensation. All of those water molecules sticking to it that are in the air surrounding it, because it's cooler than the air surrounding it. But in the sky, again, it's those dust molecules that are having all those water molecules sticking together. So we are continuing talking about the water cycle. And the part of the water cycle that I'm standing in right now is called precipitation. So we've already talked about evaporation, which is when all those molecules get really excited. The heat is added by the sun or whatever heat source is there, and they rise into the air because they get really excited and turn into a gas, water vapor. They rise up because they're hot and excited. So as they rise up, they cool down, and when you cool down, you get less excited, you start to calm down, and all those water molecules join back together into what are called clouds. So right now it's pretty cloudy because it's raining a lot. So there's a big cloud above us, there's not a lot of sunlight, and that's what's going on. How does the water come back down to Earth? Well, pretty simple. So once those water molecules form in the clouds, they get heavy and they start to fall down due to gravity, and then you get wet because you may not have an umbrella, or maybe you do and you don't get as wet, but still the ground gets all wet, and you can see all the cars getting wet and everything gets wet. Now there are 4 types of precipitation. As you can see, I'm standing in one of them, rain, but you can also have hail, you can have snow, and you can have sleet. Here in Georgia, we get all 4, depending on the season, depending on temperature, and everything like that. There are some regions of the world that get really big hail, some get really small hail. Either way, you get 4 types of precipitation, typically. Now, what's really important about precipitation is it brings the water back down to the ground in places that may not have water to start with. Such as this. If the water cycle did not exist, even Georgia may not get the water it needs because we're inland, not a lot of natural lakes in Georgia. So the water is brought to the land, and there is life. As you can see all around me, there's grass, there's trees. Right now there's not a whole lot of birds or anything because it's raining and the birds don't want to get wet. There's also not a lot of people or dogs or anything because, again, they don't want to get wet. I'm just crazy standing out here in the rain because, well, I'm just crazy. But other places such as the savannah, the water cycle is important for because it's a hot region and there's not a lot of water, and it only rains maybe once or twice a year, which is a huge amount of water in that one time of year. So all of the animals migrate to all that water because water is essential for life. You can't have life without water, which is why the water cycle is so important. Now these are the clouds I was talking about. All of that water up in the sky. It's dark and gloomy, not a lot of sunlight getting through. That's all water. And once that water gets heavy, all the rain comes down to the ground. Precipitation. Precipitation. Collection in the street. Alright, so continuing on with precipitation, part of precipitation, sort of, is called collection. And as you can see, we have a big puddle right here in these rocks. So when the water falls to the earth, it forms in what are called puddles. You don't always have puddles. Sometimes you can have ponds or lakes, whatever. But it's called collection because it is collecting in a spot on the ground. That is why your shoes get so wet in the parking lot or wherever you're walking. Now, this will obviously not stay here. This is in rocks which are over the dirt. So what's going to happen is all of this water it's going to do one of 2 things. Well, either it's going to go straight into the soil, it's going to get absorbed, penetrate deep, or it's going to get evaporated once the sun comes back out and there's a heat source. So that's pretty cool that all of these water molecules right here are forming right in front of your eyes, and you can step in it, you can play with it. Alright, so we have discussed evaporation, condensation, and precipitation. Another part of the water cycle I want to talk about is kind of my personal favorite, which is transpiration, and that involves plants, which is why I'm standing next to this plant, this kind of small tree. And I kind of did an experiment here, and this is something you can do at home. It's pretty fun. So you can see the effects of transpiration with your own eyes. You can take a little bag, put it over some leaves, and see how much water is collected from the leaves. So I put this on here a couple days ago, 2 days ago, and you can see that there is some water that is collected from the leaves on this tree. Right? You can see that. See all that water. It's pretty cool. So what happens is the plant absorbs the water through the roots. It goes up through the stem and out of the leaves. There's little holes on the bottom of the leaves. They're microscopic, but you can't see them without a microscope, but they're there. But they're called stomata. And what happens is the stomata open, typically more at night, because the plants don't want to lose too much water during the day. So all of that water will evaporate into the air. All right, and this is one reason why places like the rainforest get so much rain, is because there's so much plant density. There's so many plants there. All that transpiration, all that evaporated water from the plants collects into clouds, condenses into clouds in the sky, and then it rains. So the more plants you have in an area, typically the more it's going to rain because of transpiration. I just think that's really cool. Now, we talked about evaporation, we talked about condensation, we talked about precipitation and transpiration. The final thing I want to talk to you about what the water cycle is called runoff. Now, obviously today it's not raining, so I had to improvise, so I had my hose. But you can see here, I have my hose going, and you can see all of this water running down the ground. So it's not actually sinking into the ground. Some of it is, but the majority of it, you can see, is just washing down the ground. It's washing down the hill. My yard back here is slightly downhill. So that's one thing that can happen when it rains, is that instead of soaking into the ground, instead of absorbing into the ground, it just kind of runs downhill. It runs over the land into a stream, into rivers, into oceans, whatever the nearest body of water is. And that's why it's so important to watch what we put in our grass, because obviously, as you can see, anything that's on the grass is going to get washed away. So things like fertilizers, pesticides, whatever is in your yard, that can get washed away into those bodies of water. Now, something else you might notice is how it kind of shapes the land. So this is part of erosion. Once that water goes over the surface, it's going to take a little tiny bit of sediment or little bits of rocks or soil with it. And that's going to shape our land. Now, this is obviously a very small example of that. You can have other examples, like the Grand Canyon is probably the coolest and biggest example that I can think of anyways, at least on the surface, on the dry surface. So over time, the water will just cut away into the land, taking little tiny bits of sediment with it. So just takes a little tiny bit of sediment with it, and it carries it somewhere else. Now, erosion itself is not actually the breaking down. That's the transport of the sediment. The actual breaking of the rock or the soil is called weathering. So when it actually hits it and breaks the sediment off of the surface, that's weathering. When it transports the sediment, it's called erosion. And wherever it lands, wherever the sediment settles, that's going to be called deposition. So things like your beaches, when you go on vacation, you like to play in the sand at the beach, I'm sure. A lot of that sand is caused by deposition. So the sand gets placed right on the beach and it gets built up. Now, obviously this is going down the hill, it's going over the top of the surface, but you also have, when it gets absorbed down into the ground, it can go really deep down into what's called groundwater and kind of do the same sort of thing, just deep underground, and that can get to a water source too. Right, and if you can hear the dog in this, I am sorry, that's my neighbor's dog. Nothing I can do about that.